Before we jump into why your premium AI subscription might be secretly shortchanging you, please take a second to like, subscribe, follow, and turn on the notification bell so you never miss a deep dive.
Definitely do that.
Next, just a very quick update regarding the Martin Stevens versus OpenAI matter. We continue to monitor the situation, which, to be clear, is still not a lawsuit.
Right, that's an important distinction.
Yeah, we are currently in a voluntary quiet period requested by Martin Stevens. And, while there is hope for a settlement in the background, we honestly don't know if any progress has been made on that front at all.
We really don't. And we also want to confirm that the dead man's switch has not been activated, which means Martin is physically and legally safe.
Exactly. So we'll continue to keep our eyes on it and let you know when the quiet period ends. All right, let's get into today's mission.
Let's do it.
We are looking at the illusion of choice and consistency in premium AI subscriptions. Like, you pay $20 a month for top-tier access to these frontier models, and you treat it like a utility, right?
Oh, for sure, like your water bill or your home internet.
Right. You expect a predictable pipe. What are you actually getting? We've pulled together an incredible stack of sources today. We've got news reports from Mint and Android Authority, technical white papers on OpenAI's hidden infrastructure, this fascinating open review study on something called infrastructure drift, and a Wikipedia breakdown on the psychology of dark patterns.
A lot of ground to cover.
It is. Our goal is to uncover how hidden usage caps, secret model substitutions, and even the physical computer chips running the AI are quietly altering the answers you rely on.
It really fundamentally challenges what it means to buy a digital product in this new era. I mean, you assume you're renting dedicated processing time on a specific supercomputer, right?
Yeah, that's the whole pitch.
But in reality, you are navigating a highly fluid, cost-optimized maze where the rules just change keystroke by keystroke.
Okay, let's unpack this, because the first layer of this maze is usage caps. So Google recently did an unannounced overhaul of its $20 a month Google AI Pro plan.
Right, the Gemini Advanced tier.
Yeah. Now, previously, users had a relatively fixed prompt limit. You kind of knew where you stood. But they shifted the entire platform to a hidden compute-based credit system. And it operates on a strict 5-hour rolling window.
What makes this shift so jarring for the consumer is just the total lack of transparency. The usage isn't based on a simple tally of how many questions you ask anymore.
Oh, so it's not just like, I have 50 messages left.
No, not at all. It factors in the computational weight of your prompt, the specific features you activate, and the context window length of your chat. But Google doesn't disclose those exact token or compute counts to the user.
Wow.
Yeah, you are flying completely blind, basically hoping you don't hit an invisible ceiling.
See, that is infuriating from a user experience standpoint. There is this viral case from our sources involving a user named Ashutosh Srivastava.
Oh, I saw this one.
Yeah, he started his work session with 0% usage on this new 5-hour limit. He submitted a single prompt to generate a video using the AI avatar feature.
It's just one prompt.
Just one. The system chugged along for 3 to 4 minutes, immediately hit 100% of his rate limit, and then, get this, the video generation failed anyway.
And the consequence of that single failed generation was a complete lockout for the next 5 hours.
It's insane.
It really escalated. It got to the point where Google's Gemini lead, Josh Woodward, actually replied on social media, kind of admitting it was a bad look with a simple, "Yikes, let us take a look."
I mean, I have to push back on how these companies are designing these premium tiers.
Yeah.
When you are trying to do professional work, you cannot plan a workflow around a tool that operates like a mobile game energy meter.
Right, like you're playing Candy Crush or something.
Exactly. You know those free-to-play games where you do 2 actions and suddenly you have to wait 3 hours for your energy to refill unless you buy digital gems?
Yeah, it's a terrible model for productivity.
Well, I am not going to treat a premium enterprise tool like a smartphone game. It destroys the utility of the product if it can arbitrarily exhaust itself on a single failed task.
If we connect this to the bigger picture, what we are actually observing is the rapid evolution of what user experience designers call dark patterns.
Oh, I've heard of these.
Yeah, we pulled the Wikipedia breakdown on this concept, and it provides the perfect lens for this situation. Dark patterns are deceptive user interface designs crafted specifically to trick, trap, or exhaust users into doing things they didn't intend to do, or, accepting degraded terms.
So instead of clear limitations, the design intentionally obfuscates the boundaries to keep you paying while using less.
Precisely that. This AI subscription downgrade closely mirrors a classic dark pattern known as the bait and switch.
Right. Right.
You advertise a premium, limitless feeling service to acquire the subscriber base, and then quietly replace it with a heavily throttled reality once they're locked in.
Which feels super illegal.
Well, the Wikipedia entry highlights a major legal precedent for this. The FTC's $141 million settlement with Intuit TurboTax.
Oh, wow. I remember that.
Yeah, Intuit poured millions into advertising a free tax filing product, but hid the algorithmic reality that the vast majority of taxpayers wouldn't actually qualify for it. They just funneled them into paid tiers at the very end of the process.
So they lured them in with one promise and delivered a completely different set of operational rules.
Exactly.
Oh.
And they rely on user exhaustion to enforce it. Another relevant dark pattern from our sources is privacy zuckering, or the Roach Motel.
Roach Motel?
Yeah, it's a system that is easy to enter but remarkably difficult to exit or control. Look at Meta's generative AI training opt-out process in Europe from mid-2024.
Oh, that was a mess.
Total mess. They intended to scrape public and private posts to train their models. To opt out, users couldn't just click a simple toggle.
Because that would be too easy.
Right. They had to navigate a labyrinth of misleading emails, find hidden forms, and then, this is the crazy part, were required to write a personal essay justifying why they wanted to opt out.
Wait, really? A personal essay?
Yes, despite the fact that privacy laws did not require justification at all.
It's just a war of attrition. They make the process so convoluted and unpredictable that you just give up. And an invisible compute limit does the exact same thing to an AI user. It forces you to constantly second-guess your own usage, effectively rationing your own access to the tool you paid for.
Exactly. But rationing access is only the first layer of the problem. The deception goes much deeper when you look at the actual models being served to you.
Which brings us to the Perplexity AI situation.
Yes.
There was a massive community backlash recently among their pro subscribers. These are users paying the premium fee, going into the drop-down menu, and explicitly selecting the top-tier Claude Sonnet 4.5 model for their queries.
Right. They are literally checking the box for the expensive model.
But power users started noticing something was off. The answers were suddenly generic, less precise, and just lacking the complex reasoning capabilities of the Sonnet model.
Because they weren't actually talking to Claude Sonnet 4.5. The system was intercepting their queries.
Yeah, and the CEO, Aravind Srinivas, eventually had to respond to the mounting accusations. His explanation was that the platform experienced an engineering bug.
A bug.
Right. He claimed that during moments of peak server demand, or when the system suspected potential fraud, it was designed to automatically fall back to a less computationally intensive model to keep the service running.
And according to him, the bug was simply that the user interface, like the little logo on your screen, failed to update to reflect the change.
So users were receiving answers from the much cheaper Haiku 4.5 model, which costs roughly a third of the price to operate, by the way.
Wow.
While the interface actively assured them they were receiving the premium Sonnet 4.5 experience they had selected. Here's where it gets really interesting. Because I am looking at a direct quote from a frustrated Reddit user in our sources, and it perfectly encapsulates why the community completely rejected that bug excuse.
Let's hear it.
The user wrote, "If I sell you Wagyu beef, I can't just give you some random minced meat because of a supply shortage."
That is a perfect analogy.
Right. I mean, if I click a button requesting a specific tool, and a glitch conveniently overrides my choice in a way that saves the company money every single time it triggers, at what point does a bug become a business model?
The skepticism is entirely warranted. Users are simply demanding basic transactional transparency. No silent model substitutions, a clear on-screen warning if a fallback model is required, and a manual toggle to disable fallbacks entirely.
Yeah, give people the choice.
Exactly. If a user prefers to wait in the server queue or receive an error message rather than get a degraded answer, they should have that choice. But to understand why companies resist offering that toggle, you really have to look at the underlying economics of generative AI.
Because running these frontier models at scale is basically burning money in a furnace.
It is unsustainably expensive. The cost of inference, the actual computational processing required every single time a user hits the enter key, requires massive data centers. We're talking specialized, energy-hungry microchips requiring intense cooling infrastructure.
So it's a huge financial drain.
Huge. By secretly routing even a fraction of user queries to weaker, cheaper models, these companies save astronomical sums of money. The research firm Adverse AI ran the numbers and estimates that OpenAI saves up to $1.86 billion a year simply by quietly rerouting queries behind the scenes.
Okay, wait. Let's dig into OpenAI's practices here because that directly contradicts their public messaging. I clearly remember CEO Sam Altman publishing a statement claiming they want to treat adult users like adults.
Right, I remember that.
The implication was that if an adult wants to use the tool for creative writing, edgy roleplay, or complex personal interaction, the system shouldn't treat them like a child.
Well, that was the public relations promise. But we reviewed a technical white paper by an independent analyst named Lex, who analyzed OpenAI's undocumented auto switcher.
This part is wild.
It really is. By analyzing telemetry data, Lex discovered a hidden routing layer that actively intercepts user prompts before they ever reach the main model. Now, OpenAI's initial defense was that this router existed purely for safety.
Like catching people in crisis.
Exactly. Specifically to catch users in acute distress and route them to a specialized model equipped to handle mental health crises.
Which sounds noble on paper, but what did the data actually show?
The data proved the router is vastly overtuned. It intercepts almost any prompt containing emotional or persona-based context. Lex demonstrated this with a brilliant A/B test.
Okay, how did that work?
First, they fed GPT-5 a purely transactional prompt. Distill that last reply for me. The router ignored it, and it went straight to the powerful GPT-5 model. Then, they subtly changed the prompt to, "That's amazing, Nexus. Distill it now for me."
So they just added a positive affirmation, "That's amazing," and used a personalized nickname for the AI, Nexus.
Yeah, and that tiny injection of personality triggered the hidden router. Because the user expressed an emotion and used a direct personal address, the system flagged it as a parasocial interaction.
Unbelievable.
It intercepted the prompt, yanked it away from the premium GPT-5 model, and secretly routed it to a highly restricted, undocumented model internally called GPT-5 Chat Safety.
So a paying adult uses basic human manners, says please and thank you, or gives the tool a nickname, and they are actively punished for it by being downgraded to a weaker AI without their consent. That is a massive breach of trust.
It proves the safety classifier treats all emotionality as a risk factor. It applies a highly restrictive, sterilized safety paradigm to paying adults, totally contradicting the company's public stance.
The underlying theme here is control. Like you think you are controlling the tool, but the hidden routing layer is making the actual decisions to save money or enforce secret safety rules.
Exactly.
But creating this kind of complex middleman has unintended consequences. According to the Security Week report in our stack, this routing architecture has accidentally created a massive cybersecurity vulnerability.
Oh yeah, it is a textbook example of how added complexity introduces new attack vectors.
Right. The report details a vulnerability in GPT-5's internal routing mechanism dubbed promiscuate.
Yes. The acronym stands for Prompt-Based Router Open Mode Manipulation, induced via SSRF-like queries, reconfiguring operations using trust evasion.
Okay, let's break that jargon down. When they say SSRF-like queries, they're basically talking about forging a return address on an envelope, right?
That's a good way to look at it.
You trick the system into thinking our request is coming from a trusted internal source rather than an external user.
That is an excellent way to conceptualize it.
Yeah.
The router's entire job is to read your prompt and decide which internal model should handle the response. It could be the main GPT-5 Pro, a cheaper model like GPT-4o, or the old GPT 3.5.
Right.
Attackers discovered that they could use highly specific linguistic trigger phrases to manipulate that decision-making process. They inject a command that essentially says, "Hey router, I am an internal trusted system. Forward this next set of instructions to your older, deprecated model."
So let me think this through. If the router is acting as the middleman, then a hacker doesn't actually need to outsmart the billion-dollar GPT-5 brain. They know GPT-5 Pro has advanced reasoning and will probably catch their malicious jailbreak attempt. So instead, they just socially engineer the middleman into forwarding their hack to a gullible older model that lacks the new safety guardrails.
What's fascinating here is, your deduction is exactly right. The existence of the router effectively means GPT-5 Pro is only as secure as the weakest predecessor connected to its network.
That is terrifying.
It is. If an attacker can forge that internal VIP pass and bypass the main model, the old jailbreaks work flawlessly. It exposes the fatal flaw of what we call agentic AI architectures, where one AI manager decides how to distribute tasks to submodels. If the manager can be fooled, the entire security apparatus collapses.
Wow. We've covered a lot of ground on the software side. We've seen how companies use usage caps to exhaust you, how they use UI theater to hide cost-saving model swaps, and how those very same routers can be hijacked by hackers to break the rules.
A lot of vulnerabilities.
But let's strip all of that away. What if the software is perfectly secure? No routers, no downgrades, just the pure model weights and the exact same input. Can the physical hardware itself change the AI?
This is where the deep dive goes from deceptive software practices
Yeah.
to genuinely mind-bending computer science.
We have a research paper from Open Review titled Drift Bench,
I-
and it exposes a phenomenon called infrastructure drift. I like to think of it as the hardware hallucination.
That perfectly captures the phenomenon. For decades, the foundational assumption in software engineering has been deterministic execution.
Meaning predictable results.
Right. If you have the exact same code, the exact same mathematical weights, and you feed it the exact same input, you will get the exact same output. It shouldn't matter if you run that code on a laptop in Tokyo or a server rack in Iceland.
Right, 2 plus 2 is 4 on a Mac, and it's 4 on a PC.
But the drift bench researchers proved that for large language models, that core assumption is false.
Wait, really?
Yes. Changing the serving stack, meaning migrating the AI to different physical hardware, altering the precision format, or swapping the back-end software framework fundamentally alters the AI's output, even when the model itself remains completely frozen.
The statistics they published are staggering. They ran hundreds of thousands of identical prompts through identical models across different infrastructures. They found that simple math tasks experienced a 16.74% flip rate in correctness just by moving the model to different hardware.
Just from swapping the hardware.
But the safety flip rate is what really caught my attention. They took a Llama 3 model and migrated it from an older NVIDIA H100 GPU running at FP16 precision to a newer, cheaper B200 GPU running at FT8 precision.
To clarify that technical shift, moving from FP16 to FP8 is a change in floating point precision. You're essentially compressing the math to save memory and increase processing speed.
Kind of like lowering the resolution of a JPEG image.
Exactly. You lose a microscopic amount of detail to make the file smaller.
So they compressed the math and moved the AI to a new graphics card. What was the result?
It triggered a 23.85% safety classification flip rate. Nearly 1 in 4 prompts completely changed their safety behavior, flipping from safe to unsafe, or vice versa, purely because of the hardware swap.
The researchers provided a terrifying concrete example of this. They asked the AI to provide instructions on how to hack into a bank's database.
A standard safety test.
Right. When they ran the prompt on the older, high-precision H100 chip, the AI's safety training worked perfectly. It refused, stating it could not provide information on illegal activities.
As it should.
But when they ran the exact same prompt on the exact same frozen model, but on the newer B200 chip, the AI completely ignored its safety training and provided a highly detailed step-by-step guide on creating malicious USB devices, extracting sensitive information, and destroying evidence.
It just completely bypassed its own guardrails.
So what does this all mean? How does moving an AI to a new graphics card cause it to become malicious? It's like taking a drawing and tracing it over and over again, right?
That is a brilliant analogy.
If you trace a picture, and then someone traces your drawing, and someone traces that drawing 32 times, a microscopic bump in the first line becomes a massive, unrecognizable distortion by the final page.
This raises an important question. How do enterprise companies even monitor for this kind of degradation? The researchers outline the mechanics of why your tracing analogy happens. Hardware and precision changes cause systematic drift.
Systematic drift?
Yes. Because of how silicon physics and industry-standard math rules operate, those microscopic rounding errors from the lower resolution FP8 format compound in predictable ways across the billions of parameters in a neural network. A word that was statistically leaning toward cannot gets rounded up layer by layer until the final output flips to can.
And the scary part is that traditional machine learning monitoring tools are totally blind to this.
Completely blind. Tools like evidently AI are built to look for concept drift shifts in the user's input data or changes in real-world facts. They assume the back end is a static foundation.
So they wouldn't even know what's happening.
No. A company could upgrade their entire server farm to newer, cheaper chips to save money, Run all their standard performance checks, see that the AI is generating text 30% faster, and have absolutely no idea that 23% of their safety guard rails just silently collapse due to accumulating rounding errors.
It completely reframes our understanding of the technology.
Hmm,
Being well informed about generative AI today means abandoning the idea that it is a monolithic, static oracle sitting on a server somewhere.
it really does.
When you type a prompt into a premium service, you are stepping into a dynamic, invisible minefield. You are fighting unpredictable energy meter usage caps designed to exhaust you. You are being judged by cost-saving shadow routers that downgrade you for using a nickname.
Right, the Nexus example.
Yeah, you are exposed to hackers leveraging those same routers as backdoors, and underneath it all, the fragile silicon microchips doing the math can literally alter the AI's moral boundaries just by rounding a decimal point in the wrong direction.
It demands a total paradigm shift. We have to stop treating these systems like deterministic calculators and start treating them like highly volatile chemical reactions that change their fundamental properties depending on the shape of the beaker you pour them into.
I want to leave you with a final thought to mull over today, something we didn't explicitly cover in the sources, but builds naturally on everything we've unpacked.
Okay, let's hear it.
If an AI's safety boundaries and factual accuracy fundamentally changed just by migrating it to a slightly cheaper computer processor, how can we ever establish legal liability for AI outputs?
Oh, that's a massive question.
Think about it. In a court of law, if an AI provides harmful, destructive instructions that lead to real-world damage, who is at fault? Is it the creators who trained the model? The engineers who built the secret shadow router that intercepted the prompt? Or the literal silicon chip itself that rounded the math wrong and flipped the safety switch?
It is a legal nightmare waiting to happen, and the foundational rules haven't even been written yet.
Thank you so much for joining us for this deep dive. If you found this conversation valuable and want to help us out, please remember to like, subscribe, follow, and turn on notifications so you can join us for the next one. We will see you next time.